So when you're programming your business application using dates, calendars, and related computations, you probably want to encapsulate the details about these computations in a dedicated classes that you can have in your application. So a couple of examples here would demonstrate this technique. So let me again move this demo to a separate method, and I'll name it demo 3, and here we'll just start with a blank version of main for our demonstrations. So let's first take an example of this class. So this is called DateUtils, and so I'll just create this class in my package. Just say new Java class, and then just say DateUtils. Okay, so we'll just finish that. Again, I'll just get rid of these Java docs for now, and I'll just do my typical decorations around the body of my class. And now I'll just take the internals of these example and place it like this, and of course what I'm going to do is first of all I'll just use source format, and then I'll try my Alt-Enter trick to say I want to import util date, and I also want to use date format. So Alt-Enter on top of this and say add import. So now we've got these imports. I will make this internally stored date private. Okay, so that's something that I'm using internally, and it's actually, there's a typo here. This should be a current date. Okay, so I'll change this to a current date. So the idea is that we would like to use some kind of class where we can store the date, but on top of this date we can if the user wants to use the date directly, we can return the reference to this date, and if they want to get the formatted version of it, we may already decide what kind of format we want for our application, and do it internally in get formatted date, so that you don't have to deal with date format directly with specific instance, with specific style and all of this. You just return the string which will visualize the current date stored here internally. So just obviously some of the stuff begins to encapsulate the logic of these steps that we use to get the desired result. So in addition to this, there is DateUtils demo class, which I will also create. Okay, so I'll just create this. It's called utility class. Remember, utility class is I'll just say new Java class. And utility class means that all of the methods in that class are static, so they're just routines to do certain computations, and the class does not store any internal state. It doesn't have to be instantiated. It doesn't have any data attributes that it preserves in its instance. So I'll just create this. And once again, I'll just copy and paste the internal implementation. So I call this DateUtils right here. And so I'll just copy and paste from this slide all the code that comes with this. Okay, and so let's take a quick observation of what we have here. Well, first of all, I'll just try to fix imports, and it comes up with a calendar with date and Gregorian calendar, all of the classes that we already discussed in our series in this week. And so there are things that we do here specifically. These are again our milliseconds in a day, computed like this. And also we have get current date. So this get current date returns a date. However, what it does, it goes ahead and sets hours, minutes, and seconds to 0. In accurate computations, when you need to compute the differences between the dates in terms of days, you very likely have to make the step somewhere so that you don't have to rely on in your difference computation on the presence of hours, minutes, and seconds. In other words, you just want the pure calendar date, regardless whether it's 1 o'clock in the morning or 3 o'clock in the afternoon. So that's why you want to set hour, minute, and seconds to 0. So this current date version will return, basically generate this date, which will have all of that set to 0. So it will have only year, month, and day components in it. Another method, create date, is simply takes year, month, and day and constructs a Gregorian calendar from here and returns a date. Okay, so these get current date or create date from year, month, and day. There is no constructor that you can use with the date directly, so you have to rely on Gregorian calendar as your helper class to make this happen. So here again we obtain the date, which is specific to these 3 components. Just remember that this month should be a calendar month, which ranges from 0 to 11. Now, sometimes you already have a date like this, and you want again to strip the hour, minute, and second components, all the time components, to make it exactly midnight on that calendar date. So you can do it like this, and just the idea is to take this date, strip the time, and return back the date version with the milliseconds internally pointing exactly to the midnight. And finally, here's the days difference between date 1 and date 2. So we make sure that we strip the time from the two objects that are passed to us. Then we obtain the ln milliseconds, and then we apply our formula. And oftentimes a ln integer is way too much to represent days, so you want to do your computations with the ln integer, which is a 64-bit integer, but with the rest of an application you may want to use plain integer, which is just 32-bit integer, which is quite enough to hold the value of the difference for days between the two dates. And so this is why we have this, and this is our fourth method that we have here, which represents all of these little encapsulations inside the date utility. So now, having this class, we can basically go back to our main code and demonstrate some of the usage here. So for instance, what we can do, I'll just jump to this last portion of our demonstration. And so this code actually uses this demo, this DateUtils. So we create a Gregorian calendar object right here, right? So then this demonstrates how we can get a year. Okay, that's pretty trivial. And then instead of using this Gregorian calendar directly, we use our DateUtils, and we say get current date. And we construct date object from the current date as defined here with stripped date and time. Or we can create date right? So the usage of create date is basically just specify. And again, remember to rely on calendar constants is just a much nicer approach than some sort of hard-coded integer value. And then we compute the days difference between the current date and Christmas. So this would be showing some date like this, but if we try this example in our current main method, let's just see what this does. And so the date format was not used here. We can of course fix our imports one more time, and after copying and pasting, all the indentation here is not looking good, so it's always a good idea to format the code. Just keep the default formatting, and we'll just try saving everything and running it. And so it tells me that today is January 15th and we have left 343 days until Christmas. All right, so this is just a series of techniques that may be good to remember with the logic in your application related to dates, times, and calendars. So that is your summary overview of these components in Java library.